Welcome to the Matrix.
A user-friendly matrix calculator with fundamental matrix operators. Let's begin calculating. Here we'll find 8 different fundamental matrix operations. We'll begin with RREF. This is the input screen where the user will enter the matrix whose RREF they're trying to find. The user can input the number of rows and columns, and the matrix will change accordingly. Notice how when the user clicks on each cell, it is highlighted. Once we click calculate, we'll get a step-by-step solution on how to find the RREF of the matrix. And here's our answer. Now we can go back to the matrix and reset it so we can try another one, or we can go to the menu and try a different operation. On to multiplication. The multiplication takes 2 matrices, and the calculator will note when the matrix multiplication that the user is trying to perform is legal and when it's not. For example, if the user tries to do the following, it will get a message saying that the matrix multiplication is not legal. That is because the number of columns does not match the number of rows here. So, let's try a legal matrix multiplication to show how this operation works. Once we click calculate, we'll see that these are the 2 matrices whose product we're trying to find. Now, step-by-step explanation on how to get the different elements of the result matrix. And here it is. Now, BASIS shows a very specific feature of our calculator, which is showing the intermediate steps that it takes for an operation. So once we click calculate, not only will we find the different bases, but it will show us the RREF steps, because these steps are needed to get the following. And that is a nice feature of our calculator. No need to go back and see how to get the intermediate steps of functions. It would tell you. The determinant only exists for square matrices, and the calculator will tell you if the matrix that you're trying to input is not square. But let's try the determinant for a square matrix. Now here's finding the determinant by summing the cofactors of row 1. It is a step-by-step explanation. This function is algorithmically complex because it is recursive, and it calls itself a few times until we reach our base case, which is a 2x2 matrix, and here is the sum of all the cofactors, which is the determinant inverse. This calculator will know when a matrix is not invertible. For example, an invertible matrix must be squared, so it will tell you, but also if it is square and the determinant is 0, then the inverse does not exist, and it will say non-invertible matrix. Here are step-by-step explanations. It tells you that we're using the following formula, which means that it's calling the determinant, it's calling the cofactor functions, but it breaks it down step by step so that the user has to go nowhere else to find a full explanation on how we got this inverse. Now we'll look at Visualize. Visualize deals with directed graphs, and these matrices are square, so of course it'll give us an error. And also, since it deals with knots and arcs, the matrix will only take ones and zeros. And now we click calculate, and we see the following graph of how each knot connects to each other. And this is our directed graph of the inputted matrix.